Welcome back to our object-based image analysis tutorials and image classification with Python. In the last video, we determined the classes or determined the segments that represented each class or land cover type and asserted that none of the segments represented more than one class. In this video, we're going to move on to the actual classification part where we train a classification algorithm. So this is kind of the exciting part, and where all our previous work that's been a lot of kind of pre-processing is going to come to a head and result in our image classification. So hopefully we get through all of it in this video. I try to keep these videos between 15 and 20 minutes long. So if we get going too long, I'll stop the video and we'll finish in the following one, but I'm hoping we can get through it in this video, so stay tuned. The first thing we want to do is create our training image, and that we're going to call train img. And it is just going to be a copy of our segments, okay? Oh, sorry, we're going to do np.copy segment. So this will create a new numpy array, and it's going to be our training image. Now, the next thing we need is we need to get a threshold. So we want to find what the maximum segment value is, and we're going to need that because we're going to give our training segments new values. We want those to be greater than our maximum segment value. So I'm going to make a threshold variable, threshold, and we want to set that so that it's greater than the max of segments. And we'll do that with train img.max plus 1. Okay. All right. So we have our threshold and we have our training image now. And it looks like I've misspelled threshold here, so we'll just fix that real quick. Okay, so now what we want to do is we want to loop through our classes. So for class, and we're going to loop through all the classes we have, which we have in the variable classes. And for each of these classes, we want to find all the segments associated with them. And we want to change in training image the class to be something that we know. Okay, so we're going to call this class label, and this is going to equal threshold plus class. Okay, so these classes are going to have a label that's greater than the maximum value in our segmented image. Now for each segment, we want to set that segment equal to this class label so we know that it represents a certain class. Okay, and so we want to do for, we'll call it segment ID in, and here's where we have our segments per class for the specific class we're working with. And we're going to set that segment ID equal to our class label. And we want to do it in the training image. So we want to do train img. We want to do where train img is equal to segment ID. It's going to equal class label. Okay, and so that'll change the values in our training image to class label, where the training image is equal to the segment ID. Okay, so that means any segment ID that represents, for example, a road will have this same label, which will be threshold plus class. So we can identify all the pixels that are roads, all the pixels that are water, and so forth. Okay, so once we've done this, we can alter our training image to only show the class values, and I'll show you how we can do that. So we're going to do train img, and where our training image img is less than or equal to threshold, we're going to make it 0. Okay, And then where our training image is greater than threshold, we're going to subtract threshold. And so what this will give us is we'll get an image where the segments that have no training data are classified as 0, and the segments or cells that have training data will be classified with our class number. And I'll show you that class number again. We created this file in a previous video where road is equal to 1, trees 2, water 3, urban 4, bear is 5, meadow is 6, and shrub is 7. Okay, and so that's what we'll see in our training images. Our numbers 0 through 7, where 0 represents no training data, and 1 through 7 represent the type of data we're training to. All right, now let's move on and make a couple of lists that can be used for training. So let's do training objects. It's going to be an empty list. And training labels will also be an empty list. And once again, we're going to loop through our classes to set up the data we need to train our random forest algorithm. Now, we need to refamiliarize ourselves with a couple of variables we created a few videos ago. So I'm going to scroll up to where we did our segmentation. Okay, so here we have our segments, and we created our segmentation. And so segments has a unique number for each segment. So multiple cells have the same number, and that represents a segment. Then down here, for each of those segments, we have a segment ID right here. And then we have objects and object IDs. Okay. Now, if we take a look at objects, our objects have these features. So these features come from segment features, which is going to get the information, the statistics about each segment, okay? So objects has the data that correspond to each segment, okay? Segment IDs has the ID for each segment or each object, okay? So we had 4 ID in segment IDs, so we looped through that, and the object IDs holds a list of the IDs for each object, okay? So objects contain the statistics that we need to use for training data. Segment IDs have the ID of each segment, okay? So let's scroll back down here for now. So the first thing we want to do is find out if the segment is in the training data set for a class. Okay, so we want to do class, I think it's class train objects is what I want to call this. And we want this to be a list. And we're going to do v for I, comma v and enumerate objects right there. Okay, and so that'll give us, the index and the values of those objects. And then we want to check if segment IDs for that index are in, so if the segment ID is in segments per class for class, okay? That went a little longer. Basically what we're finding is we're getting the values. Okay, let's go through it this way. So for each object, if the segment ID for that object is in the segments representing the training data, is in a segment of training data for that class, then we're going to get the values for that segment to use as a training object. Okay, so once we have this, we now need to make sure that we have a corresponding label for each of these objects. We want that label to be equal to class, and so the way we're going to do this is we're going to do training labels plus equals, so we're going to add 2, and we want to make class a list so we can multiply it, so it'll create a list for all the objects. And we're going to multiply it by the length of class train object, okay? And so this will give us a new list that has the value of class as many times for as many objects as we have, okay? So if we have 10 segments that represent roads, we're now going to get a list that has 10 values of number 1. If we had 15 segments that represented water, we would then get a list of number 3 repeated 15 times, okay? And so that's going to give us the label that corresponds to each of these objects, all right? Now we also need to add the training objects. So we're going to do training underscore objects plus equals class train object, okay? And so now we're going to keep adding those to the training objects. Now what we can do here is we can print out the length of training labels, which will be the same as length of training objects, to make sure it lines up with the number of training segments we calculated up there. And so we'll do that with the print statement, training objects for class, and then let's give it class, let's give it a colon, and then let's give it len class train object, okay? So that will print out the number of training objects we have, which should be equal to the number of training segments we have up there. And so now we're going to have our training objects, and we're going to have labels for those training objects, and now we're ready to go ahead and train a classifier. Now before we can train our classifier, we need to make sure that it's imported. So we're going to come to the top of the file, and from sklearn.ensemble import random forest classifier. Okay, so we're going to need that. Go back down to the bottom of our file, and we're going to make a classifier equals random forest classifier, and we're going to set n jobs equal to -1. Okay. All right, now we have our classifier. Now we want to fit that classifier, so we're going to do classifier.fit. We want to fit it to our training objects and our training labels. Okay, and so that will get our classifier, and that will create a fit for our classifier. And once we fit our classifier, we can predict with our classifier. So we can do classifier.predict, and remember we have objects, and these objects represent all the segments. Now this is going to return the predicted classes or the predicted training labels. So I'm going to come back over here, and I'm going to put this into the variable predicted. Okay, so let's come in and just print some statements here so we know what's going on. So print, let's go fitting random forest classifier, print predicting classifications. Okay, so now we've trained our classifier and we've used it to predict values, and now we're going to need to save those values and apply them to our image grid. And so what predicted gives us is it gives us a list of training of labels. Those are going to be the same as training labels for each segment. Okay, and so we're going to want to loop through. Well, first of all, what we want to do is we want to create a copy of our segments. Okay, so we're going to call the CLF for classified equals np.copy segments. Okay, so now we have our segments. And for each of those segments, we want to link the segment ID to the predicted value. And if you remember, we already have a list of segment IDs. We have the predicted values. So if we can associate those with each other, we can then set CLF to equal one or the other. So we're going to do for segment ID class in zip segment IDs predicted. Okay, and so what this does is makes a dictionary that links segment IDs to the predicted values. Okay, and we're going to loop through, and we're going to do our CLF, and we want to do where CLF is equal to the segment ID, we want it to equal class. So what this is telling us is segment ID equals the segment ID here, and class equals the predicted value here. Okay, and so that'll give us CLF will now have values 1 through 7 and 0 for no data probably. We're going to do some masking here just to make sure that everything comes out properly. So we're going to make a mask to show us where we have data and where we don't have data. So we'll make a variable called mask, and this is going to equal np sum img and axis equals 2. Okay, and so what this is going to give us is it's going to give us a 2D array that it has the same number of rows and columns as our image, okay, our original image. So it's going to be just the same number of rows, same number of columns, and we can use this mask to tell us where we should have data and where we shouldn't expect to have data. And so by summing, we summed up all the intensity values in our image. So that means where we have a value greater than or equal to 0, we should expect data. Where we have a value less than 0, we should expect no data. And so what we'll do here is do mask, and we'll do mask greater than 0. We want that to equal 1. Okay, and mask where mask is less than 0, we want that to equal -1. My apologies here. This is going to give us values that are 0 or greater. So anywhere we have 0 is going to, we're not going to have any data. So we want to go greater than 0, and we'll do 0.0 just to be safe, because these are floating point numbers. We want it to be 1. If it equals 0, we want it to be -1. All right? And now we're going to do a multiplication. And that multiplication will give us positive values where we expect data and negative values where we don't expect data. So we'll do CLF is going to equal np.multiply, and we're going to multiply CLF by mask. Okay, and so where we expect data, we'll have multiply by 1, which will give us the value of CLF, and we'll get negative CLF where we don't expect to have data. And then we can go through and do CLF less than 0 equals -9999.0. And so that will be the no data value for our classification raster. Okay, so now we have our final NumPy array that shows our classifications, and we just need to save that to a raster data set in order to visualize it in QGIS and see the result of our classification. So we are getting there. Let's make a data set, a classification data set, and we will use our same driver, our TIFF driver, to create this. So driver TIFF.create, we need to give it a file name, so we'll do C temp nape classified dot tiff, and then we need to give it an x size and a y size, which can just be nape.ds dot raster x size, nape.ds dot raster y size. Let's hit enter there. The number of bands, and then we need to give it a data type, which will be GDAL, GDT, and we'll give it, we could do an int, we'll give it a float just to be safe here. I know this works with floats, I haven't tried it with ints. Okay, so we've got that data set created. Now we just need to make sure we set the geotransform projection and write the data to it. So clfds.set geotransform, and we'll do nape.ds.get geotransform, and this needs to be a capital T over here. And then we can do clfds.set projection and nape_ds.get projection. Make sure you put parentheses on the end of that function. All right, and then we need to do clfds.get raster band 1.set node data value, which will be -9999.0, and clfds.get raster band 1.write array, and make sure we write our CLF array. Make sure this is a lowercase e. And that should be all. We'll make sure this gets closed properly. CLFDS equals none. And once we run this script, that should produce this file here that we can then open in a GIS software and see what our classifications are. So I'm going to go ahead, I'm going to click run on our script, and I'll walk you through as we get these different messages. And as we get those, we can then go back to QGIS, load in our image, and see what it looks like. I'm going to add one print statement here. Print prediction applied to numpy array. And then I'm going to add one down here, which will say print saving classification to raster with GDAL, and then I'm going to type print done down here so we will know we are finished. All right, I'm going to go ahead and click run. I'll let you know if we have any errors, and we can go ahead and look at our classification once it is finished. Okay, clicking run, and I'll keep you updated here. All right, so we've loaded our image, and the next step will be to do the segmentation. Our segmentation is done, and we are now calculating the statistics for each of those segments. All right, so we're finishing up the segmentation part of this here. We're going to get to just over 48,000, then we'll be done with that. While this is going, I just want to mention that all this code is being posted on the website, opensourceoptions.com, and I will include the link to the post in the description of this video. So if you're interested in seeing the code, you can go there and get it. If you want the data we've used, you can go download those data. And there's a video to show you how to do that at the beginning of this playlist. That video is also linked in the blog post on the website. So go ahead and check that out. All right, so as you can see, we finished up with that. We create our objects. We have our training classes here, and you can see these all line up between our two training segment tests. We fitted the random forest classifier, and we are now predicting the classifications. So once we get done with that prediction, what's going to happen is we're going to run this code here to apply Yes, we have predicted it. We're applying that to our array, and once we finish that, we'll mask the array and then save that as a raster. And once we get to that point, we can pull this up and take a look at it in QGIS. And so I'll get QGIS started so we can look at that when this gets done. All right, so we've got that finished up. You can see this is done. Let's go over to QGIS and see if we can find our data. So here's my NAPE folder. I named this, I believe, classified. Let's refresh this just to be sure. And we'll go check our file name over here just to be sure. Sure enough, classified. So I'm going to drag in the classified image. And there you go. You can see we have this classified. Let's go over to our layers. It goes 1 to 7 just like we expected to. And if I change the symbology here, which I can do by going through symbology, and we can change this to single, we can do paletted unique values, and we can click classify. You can see we get a separate value 1 to 7. We can click OK, and there we have that there. Now, what I've done actually is I have made a style for this. I'm going to load the style, and we'll go to my C drive, temp, nape, and here I put land cover class style. We'll open that one, and we'll click OK. Oh, it didn't change there. Hold on just a sec. Anyway, something's wrong with that classified file I had, but you can see here we have our different land cover classes. Okay, and so we've successfully created this classification. Now, the thing we haven't talked about here yet is how we can validate that and look at a confusion matrix that shows us our accuracy with our training and our test data. And so we'll have to get to that in the next video. But for now, you can see how we've classified this image. All right, so remember to check out the website if you want to get the code. Thanks for watching. Hope you've enjoyed this series so far. And in the next video, we can go over how to get a confusion matrix and how to show what our error rates are like.